Good day, I'm Christian Lijayan, and today we are going to discuss about nanopolymers, its application, and its fabrication techniques. So to start, what are polymers? Polymers are basically everything around us, from the plastic bottles that we drink water from to the textile that we wear every day. But scientifically, polymers are substances containing a large number of structural units joined by the same type of linkage. These substances often form into a chain-like structure. So what are the classifications of polymers? So there are three classification polymers, namely the amorphous, the semicrystalline, and the crystalline polymers. So to start, what are amorphous polymers? These type of polymers are non-ordered and usually transparent, like the polymers used in plastic bottles to hold water. So these type of polymers have lower glass transition temperatures as compared to semicrystalline and crystalline polymers. This makes it easier to process as compared to the two types of polymers. So on the picture, you can see the structure of the amorphous polymers. So the structure is very random and non-ordered in a way. So the next type of polymer, we have the semicrystalline polymer. So semicrystalline polymer have some ordered regions and some non-ordered regions that correspondingly represent crystalline and amorphous regions in polymer matrices. So semicrystalline polymers are somewhere between the amorphous and crystalline polymers. So semicrystalline polymers have properties such as it has higher glass transition temperature and is stronger than amorphous polymers. This is due to the fact that it has some ordered regions. So as you can see in the picture, some of the regions of the semicrystalline polymers are very ordered and some are non-ordered. And last is the crystalline polymers. These type of polymers are very or highly ordered polymers with crystal lattices that enables the polymer to resist different types of forces. So among the three types of polymers, this is the strongest one. So what are the characteristics of a crystalline polymer? So crystalline polymers have significantly stronger mechanical properties as compared to semicrystalline and also to amorphous polymers. So as you can see in the picture, the structure of the crystalline polymer is very ordered and very structured in a way. So what are nanopolymers? So a polymer or a copolymer material containing dispersed nanoparticles. So nanopolymers is just a derivative of a polymer. It's just made up of nano-sized polymers. So why do we use nanopolymers nowadays? So when polymers are fabricated as nanopolymers, they exhibit different properties. This is because nanopolymers are significantly smaller than macromolecular polymers. This allows nanopolymers to physically interact with their surroundings in a different manner. So in a simpler manner, nanopolymers have stronger properties to normal macromolecular polymers due to their size. So that is why it is used nowadays. And next is the application of nanopolymers. So what are the applications of nanopolymers? So we have here some of the applications of the nanopolymers, which are the defense. As you can see, the ballistic protection. Next is the telecommunications. As you can see in the picture, it is a nano-sized circuit. Number 3 is the basic materials, such as the monoblocks. It gives greater strength to our monoblocks. Next is for the household, we have a anti-cracking paint. And for the medical field, we have the drug delivery system. And for the number 6 and the last, we have for the services, we have the water filtration system. So why are nanopolymers used? So in the simplest manner, nanopolymers are used because of their very desirable mechanical and chemical properties. So these mechanical and chemical properties are, it has high tensile strength, good chemical resistivity, and being able to contain metals and other compounds. So how do we fabricate nanopolymers? So there are several methods of fabricating nanopolymers, and these are drawing, template synthesis, phase separation, self-assembly, and electrospinning. But among these fabrication techniques, we have electrospinning as the most common and the most modern type of fabrication technique of nanopolymer. So what is electrospinning technique? So electrospinning technique is a method to produce ultra-fine, in nanometers, fibers by charging and ejecting solution through a spinneret under a high voltage electric field. So basically, electrospinning technique uses high voltage electric field in order to create nanofibers. And these nanofibers are used in order to produce or to fabricate nanopolymers. So how does electrospinning works? So electrospinning works by first, a polymer solution with the desired nanofiber polymer mixed with a solvent in a syringe being pumped through a nozzle is prepared. So a polymer solution of desired characteristics are first prepared by a scientist. So it can be varied depending on the output that we need. After which, a high direct current electric potential is applied between a collecting plate and the syringe. So as you can see here in the picture, there is a voltage applied on the collector and on the syringe. So this high voltage is the reason that the nanofibers are produced. Then, after applying the high direct current or high direct voltage, the solution moves toward the collector. And a Taylor cone is formed at the meniscus of the solution, from which the solution proceeds toward the grounded target. So as you can see, the solution, when applied by a current or a voltage, the solution moves toward from the syringe to the collector. Then next, after the solution is elongated, whipping occurs where the solution starts to move in a random circular motions. So in the picture, the solution is moving in a circular manner because of this induced high electric current. The solvent evaporates during the whipping process and the fiber is deposited as a solid polymer. So after the fiber has been produced, the solvent that is mixed on the solution evaporates, and this process solidifies our nanopolymers or nanofibers, and the resulting polymer is a highly porous non-woven mat. So the product of this technique is still fibers. So these fibers is the raw materials that are used in order to create a woven mat or a polymer of a specific application. The next is, how do we manipulate the thickness and the composition of the nanopolymers? So we manipulate the thickness and the composition of the nanopolymers depending on what is the purpose of the user. So in order to manipulate such, we need to first change the properties of the polymer itself. So we change the molecular weight and the architecture of the nanopolymer of the solution. Also, we change the properties of the solution, and we vary the electric potential between the syringe and the collector plate. The next is the distance to the plate. So the distance of the nozzle of the syringe to the collector, then the ambient parameters or the surrounding parameters, and lastly, we have the motion of the target, depending on how we move the nozzle of the syringe. So we have here an actual representation of our video, a small video, of how the electrospinning technique works. So as you can see, here is the nozzle from which the solution gets out, and it has a whipping action, and the collector collects the nanofibers that is being produced in the syringe. And for the next part, we have here a small video or a short video regarding the electrospinning technique in order to supplement our learning.
Electrospinning is an established technique for the manufacture of fibrous components for medical devices. During electrospinning, a syringe pump feeds a viscous solution through a needle, which is connected to a high voltage, ejecting a thin jet of the solution. The jet accelerates towards a target collector, held at an opposite potential, and thins considerably during flight. Dried fibers are then deposited as a non-woven mat, with each fiber being about 10 to 100 times thinner than the width of a human hair. Electrospun fibers can be used as simple mats and cut to shape with fibers of random, aligned, or layered orientation. The technique also allows for the coating of complex geometries and the manufacturing of specific structures like tubes. Different polymers can be used for this process, and devices can have an opaque or transparent appearance.
So that would be all. Thank you for listening.